Today we're going to take a look at solving quadratics by square roots. All right, now there's several different ways to solve quadratics. There's actually 4 different ways. Solving quadratics by square roots is probably one of the faster ways that we're going to see. There's only specific times it works, but I think you guys are going to like these as far as just the pace at which it goes. So before we do that, we need to wrap up radicals from yesterday. The one thing with radicals we didn't do on Tuesday that we're doing on Wednesday is if we are combining or basically radical operations. So the operation here is to addition, or is addition. Right? As long as whatever's under the radical is the same thing, they're basically like terms. So just like if we had 13x plus 4x, 13 plus the 4 would be 17x. Same idea here, just instead of x, we have a radical 3. So 13 plus the 4, these are like a label. So we've got 17 radical 3, that would be my answer. Okay, so 17 radical 3 would be my answer there. We got a little bit too far over there. Sorry, I'll take that out. All right, so there we go, 17 radical 3. Now this one, 19 minus the 8, again, the label is radical 7. So the radical 7's being the same. These are basically like terms that we can combine. Just like if you had 19 apples minus 8 apples. Okay, 19 minus 8, you get 11. 11 apples, or in this case, instead of apples, we got radical 7. Okay, so 11 radical 7 there. All right, so we'll see a couple of those here and there. It's just one thing I want to make sure we threw in today. Okay, that goes with radicals. That way we can kind of speed things up now that we're finding out that we're officially done basically on May 14th. So there you go. There's a quick run through on operations with radicals. We're not going to see a bunch of those this chapter, but we'll see probably one on the test. It's colder in here today, a little bit tougher to erase some of this. Maybe I need to use the this one. Get that off of there a little bit better. Okay, all right, we'll go with that. It'll be all right. Hopefully you guys can still see pretty well. All right, so for number 2, what we're going to look at is here we go, solving quadratics by square root. So x squared equals 25. All right, so this is a quadratic because of the x squared. So what makes it quadratic is the fact that its degree is 2, and that's what makes it squared. If it was the degree of 3, x to the third, that would be a cubic, not a quadratic. All right, so we want to get x by itself. We don't want x squared, we want just x. So to undo something squared, we must take the square root. And if we're going to take the square root of this side, we have to also take the square root of the other side. So the square root of x squared, our rule is that we take half of the exponent. So that becomes x to the first, which is just x. We don't have to write anything else there. And then the square root of 25, we could write this out and break it down, but you can just test these on your calculator. As long as it's a perfect square, we can just write 5. Now, one thing that we can't forget here is a lot of times, sometimes students will just circle that. But the issue is that anytime you bring the radical into the equation, it wasn't there to start with. When you bring in the radical, you have to count for positive and negative 5. So when you see this sign, that means plus or minus 5. What that's really saying is that could be negative 5 or positive 5. There's really 2 answers there, right? And the reason we have to have negative 5 is most times everybody knows 5 squared. If we did 5 squared, that equals 25. Okay? But if we have to take into account that if this were, in parentheses, negative 5 squared, negative times a negative is a positive 25. So that's why we get 2 solutions. Now, the board over here is very helpful with this because our solutions are actually where it crosses the x-axis, right? So whenever you have 2 solutions, we're at 1, 2, 3, 4, 5, that would be a solution here, and a solution back at negative 1, 2, 3, 4, 5 back here. So you're not going to have to do a bunch of this. The main thing, if we just estimated this graph, it would look something like that. Okay, that's what we call a parabola. All right, so the graph of a quadratic is parabola. So there you go. That would be if x equals plus and minus 5. This is the graph that would go with it. You don't have to do graphing in this chapter, but it's something I want to throw in because you're going to see it as we go here. All right, so there you go. Pause at any point if you need me, feel like I'm going too fast or I need to slow down. Whatever the case may be there. All right, we're gonna have to work on erasing for tomorrow, looks like. Maybe the pen's just a little bit stronger, I'm not sure, but okay, here we go. Number 3, we've got 3x squared is equal to 27. All right, so to undo something squared, we're gonna take the square root, but we can't yet because we wanna get x squared by itself. So this x squared is not by itself just yet. So we're gonna divide by 3 on both sides before we take the square root. So these cancel out and we get x squared equals 9. And then now we're back to the spot where we were on the last one. We take the square root of both sides. So x equals plus and minus 3. And so that's my answer. So once you get going with these, they really move pretty quick. Now one thing on the graph, it's not going to be the same as that last one we did. This graph is going to be at positive 3 and negative 3. And again, you're not going to have to graph these on the homework right now, but I just want to show it to you that this is what the parabola would look like. That's a ballpark estimate of what it would look like. Okay, so there's number 3. All right, number 4, let's go over here. See if we have better luck here. Erasing here in a minute. 104 is equal to x squared plus 5. Okay, so in this case, we got some bigger numbers, but again, we need to get the x squared by itself. So we're going to subtract 5 this time. We go ahead and do that. We get 99 is equal to x squared. Now what's different about this one from the first two is that now, this here we had 9, we had a perfect square root. We take the square root of both sides. 99 is not a perfect square, so we have to simplify this just like what we did on Tuesday. So we can use any factors you want. You can use 3. 2 doesn't work because it's not even. But I'm going to go 9 and 11. 9 times 11. Okay, I recognize 9 is a perfect square, so I got a pair of 3's times that 11. Okay, so I'm gonna move this over here. So I got a pair of 3's, so that is 3 radical 11 is equal to the square root of x squared is x, right? And then I'm not quite done because the radical was not part of the original. I have to account for plus and minus 3. Okay, radical 11. So this graph, I'm not gonna put this graph up here. I just don't want you to be confused by still having this one up here. Kind of take a, if you pause it, just to look at what the picture looks like. But anyways, so we can have that happen where it's not a perfect square. We'd find the decimal and still be able to graph it, okay? All right, so that is the main thing. We got one last special case I want to show you. So here we go, last one. Well, that's a mess. I have to work on that, see if we can figure that one out. Making sure this is cleaned off a little bit better. But all right, so number 5, last one, x squared plus 25 is equal to 9. All right, so on this, we go ahead just like we did the others. We're going to subtract 25. When we do that, we get x squared is equal to negative 16. Now 16 is a perfect square, so it seems like that would be all right, but we go to take the square root, and we have the square root of a negative. Now, in Algebra 2, next year, 2 years from now, whenever it is you take Algebra 2, we will talk about how we can simplify this. But for right now, we cannot do this because we cannot take the square root of a negative, so this would be no real solution. Okay? If you want to abbreviate it NRS, that is okay, but it means no real solution. What that means is the graph would not cross the x-axis, because like I talked about earlier, we could still possibly graph this x squared equal to negative 16, but it might be somewhere up here where the solution does not cross the x-axis. Those are where our answers end up. So anyhow, there's no real solution there. And that's going to wrap things up for today. Hopefully the homework that goes along with this goes pretty well. If you have not finished the test from the factoring test, I do want to say this, I mentioned this at the end of the video today. Make sure we're getting on top of that. I sent out a message to those of you who have not taken it yet. We need to figure out when to do that. And then as far as the work goes, putting in the daily effort is the main thing right now. Pick up on as much as you can, and you'll do all right on these tests. Now, obviously, we have a shortened version of everything right now, but the main thing is, your understanding, okay, and trying to pick up on things as much as you can as we go, and do the best you can with the situation we've got right now, just like everybody's trying to do. So thanks for your time today. And if you have any questions, make sure you send me a Canvas message, and I'll get back to you as soon as I can. All right, thanks, guys.